Alright, section 2.6, polynomial and rational inequalities. Let's consider the following situation. Let's say I want to solve the product x plus 2 times x minus 3 is negative. So here I have two factors, namely the first one, which is x plus 2, and the second one, which is x minus 3. And the product of two things is negative precisely when one of the factors is negative. Let's study the variation. So I'm gonna just say we first study the variations of each of the factors. What do I mean by variation of each of the factors? I mean that I want to know when x plus 2 is negative, whereas x plus 2 is 0, and when x plus 2 is going to be positive. And likewise, I'm going to do for the other factor, which is x minus 3. Let's start with the first one, x plus 2. So when is x plus 2 negative? Well, x plus 2 is negative. This is a linear inequality in one variable. This happens precisely when x is smaller than negative 2. Where is it neutral? Where is it 0? Well, x plus 2 is equal to 0. That's exactly happening when x is equal to negative 2. And x plus 2 is greater than 0. That happens precisely when x is greater than negative 2. So I know exactly where this factor, the first factor, x plus 2, I know the variation of this factor x plus 2. Let's move on and study the variations of the other factor, which is x minus 3. So x minus 3 is negative precisely when x is smaller than 3. Similarly, x minus 3 is 0, which is neutral, if and only if x is equal to 3. Let me fix this. And x minus 3 is positive precisely when x is greater than 3. Very good. So let's understand what we have so far. So let me move this thing here. All right. So I know the variations of each of the factors, and we said before that this product right here is negative precisely when one of the factors is negative and the other is positive. So this happens, this is one of the situations right there. If x plus 2 is negative, and x minus 3 is positive, so these two together force the following conclusion, that the product, the desired product, is negative. So this is one of the two scenarios that may happen to force the product to be negative, and the other is if x plus 2 is positive and x minus 3 is negative. So these two things together force the following conclusion, which is x plus 2 times x minus 3 to be negative. And these are the only two situations where the product is negative. So let's summarize our work. So in summary, this is what we have. In summary, we have that the product x plus 2 times x minus 3 is negative if and only if either the red part that we just discussed above, which means this guy is negative, in other words, when x is less than negative 2, and remember the red part is when also this guy happens, this statement holds, which means x is greater than 3. So if this statement holds, or the other statement, the green statement, which is when x plus 2 is positive, which means x is greater than negative 2, and when x is smaller than 3. Correct? So if one of these two statements holds, then the product is guaranteed to be negative, and this is an if and only if statement. Excellent. Let's look at this. Take a look at this guy here. Think about it for a second. X is less than negative 2 and x is greater than 3. Well, if x is less than negative 2, certainly it cannot be bigger than 3. So this statement is not offering any such an x, right? So because there's no way an x can be smaller than negative 2 and simultaneously bigger than 3. So this doesn't offer any solutions. So this has no solutions. Correct? And the other one, x is greater than negative 2 and x smaller than 3. This may happen. I mean, 0 is such a number. I mean, any number between minus 2 and 3 is such a number. So this whole thing reduces to the following. X bigger than negative 2 and x smaller than 3, which means that x is between negative 2 and 3. Correct? So we know now exactly when the product is 0. The product is 0 again. The product is, when the product is negative. The product is negative if and only if this happens. Very good. Even though this discussion is great, but as you may guess, as the number of factors increases, I mean, look, here the number of factors is 2, right? So this is one of the factors and this is the other that made up the product. If the product is made up of maybe 7 factors, it would be a nightmare to just list all of the cases. I mean, for 2 factors, look, I wrote like half a almost all, an entire page, and I spent a good amount of time to consider the cases. If I have more factors, obviously it's that discussion is gonna be lengthier, and a lot of cases have to be considered, and it would be a nightmare to list all of them. As such, I'm gonna appeal to, I mean, the same spirit of the same line of reasonings are gonna apply, but now I'm gonna embed them in a table which I'm gonna refer to as the table of variations. So all of the information mentioned are gonna be just in a compact format, which is the table. Okay, so let's go for this. Just fit this to the screen. What's a table of variations? Actually, let me just rewrite the problem. So the problem was, again, we wanted to solve this product x plus 2 times x minus 3 negative. So as I said, I'm going to appeal to something referred to as the table of variations, where I'm going to embed all of the information I had before, but in a compact way. Okay. All right, so how does it go? So I'm going to have a table. And I'm going to have a row for each of the factors I have. So I should have a row for the first factor, which is x plus 2. And a row for the other factor, which is x minus 3. Right? Very good. And the first row, I'm gonna think about it as the number line. So the number line, which means all numbers that are between minus infinity and plus infinity. I'm gonna have the critical numbers that force any of the factors to be neutral, which means where x plus 2 is 0 and where x minus 3 is 0. So x plus 2 is 0 happens when x is minus 2, and x minus 3 is 0 when x is 3. So these I'm going to refer to as critical points, because at these points one of the factors is going to be 0. Alright, and now I'm going to drop bars right below these guys. Very good. So x plus 2 is neutral, which means 0 at when x is negative 2. So x is negative 2 forces x plus 2 to be 0. And which means before that, x plus 2 is going to preserve one sign because it doesn't neutralize again before minus 2. And that sign is negative, because choose any, since before minus 2 the entity x plus 2 is going to preserve one sign. Just choose any number before minus 2 and check. For example, check at minus 3. If x is minus 3, x plus 2 is going to become minus 1, and as such the sign is going to be negative. And after negative 2, x plus 2 is going to be is going to preserve one sign, and that sign is going to be positive this time. You can check, take any test point after minus 2, for example 0. If x is 0, 0 plus 2 is going to be plus 2, which means the sign is going to be positive. Again, x plus 2 neutralizes one and only one time, which is at negative 2. It cannot neutralize anymore for any other number. This is why before minus 2, the entity x plus 2 is preserving one sign, and after minus 2, it's preserving a sign as well. Likewise, I'm going to play the game for x minus 3. X minus 3 neutralizes at 3, which means before is going to preserve a sign, before 3 is going to preserve a sign, and after 3 is going to preserve a sign. Let's check what the sign that's gonna preserve before 3. So take any number before 3 for x. Okay, maybe 0. If you choose x to be 0, then x minus 3 is going to be minus 3, and hence the sign is going to be negative. So when x is smaller than 3, the sign of the entity x minus 3 is negative. I'm going to refer to it as minus in the table. And after that, choose a number bigger than 3, let's say 4. 4 minus 3 is 1, which means a positive entity. So x minus 3 for x bigger than 3 is going to be a positive entity. So what is this table? You see each of the rows that you see here? These are the same thing as we had above in purple and blue. They are right there. Let me just zoom out. Okay, what's going on here? I don't know. Okay, there you go. You see the purple discussion that we had before? It's embedded in this row right there. You see, x plus 2 is negative when x is smaller than negative 2. It's right there. X plus 2 is 0 when x is negative 2. It's right there. And x plus 2 is positive when x is greater than negative 2, which which is right there. And similarly for the blue information that we have here, they're embedded in this row. And obviously, the added benefit that this table has is that it gives us a compact way of representing all of the information that we had before. Very good. Now, what we want is, we would like to understand when this entity here, this product, let me refer to it as P for product. I want to know when this product is negative. Well, let's create a row for this product P. Let's have it as the last row. The product P is made up of x plus 2 times x minus 3. And between minus infinity and minus 2, x plus 2 has a negative sign, and x minus 3 has a negative sign. So P, which is the product of the two, is going to be minus times minus, which is a plus. One more time. When x is between minus infinity and minus 2, this factor here, x plus 2, is negative. And this factor, x minus 3, is negative, which means the product P, which is negative times negative, is going to be positive. Very good. What happens when x is negative 2? Well, when x is negative 2, the entity x plus 2 is 0. And that forces the product to be 0. Because one of the factors is 0. Let's keep going. When x is between minus 2 and 3, the first factor x plus 2 is positive, and the other factor x minus 3 is negative, which means the product is going to be plus times minus, which is going to be minus. At 3, when x is 3, one of the factors is 0, namely x minus 3 is 0, and hence that's going to force the product to be 0. And once x exceeds 3, both of the factors are going to be positive, and hence the product is going to be positive. And finally, let's respond to the question. The question again is, I want to know when this P is negative. Well, just look at the last row at this point. I want to know when P is negative. It's right there. This is where it's negative. And this happens when x is between minus 2 and 3. So this is where it happens. So the conclusion is, from the information that we embedded in this table, we can say that P is negative if and only if the x is between minus 2 and 3. As found before. I mean, just to be very clear, this is exactly what we found in the previous discussion right there. But obviously this is a much shorter, and you'll appreciate it more once you have more factors. This is a way more compact solution, let's say. Now a problem from the book. Let's go to page 333, number 21. So let's solve this question. Solve 4w squared minus 9 being non-negative. Well, I would like to write 4w squared minus 9 as a product of two things, as we had before. And this is not too hard to see that this is 2w minus 3 times 2w plus 3. Why? Because this is of the form a squared minus b squared, right? I just look at this. This is the same as 2w squared, and this is the same as 3 squared. So this is the form, this is the difference of two squares, and this can be written as a minus b times a plus b. Excellent. All right, so this is again a product. I would like to understand when this product is non-negative this time as opposed to negative before. I'm going to create the table of variations again. And the number of rows is going to be dictated by the number of factors I have, which is exactly 2. So I'm going to have one row for 2w minus 3 and one row for 2w plus 3. So 2w minus 3 is going to be, let's say, the first one, and 2w plus 3 is going to be the second one. And what are the critical points in this context? Well, the first factor, 2w minus 3, is 0 when w is equal to 3 over 2. So I'm going to record this in pink right next to it. So when w is 3 over 2, this guy is 0. And the other guy is 0 when w is minus 3 over 2. So these are the two critical points that I have to embed in my table. And obviously, since the first row is the number line, I'm going to respect the order. Which one is smaller? Minus 3 over 2 is smaller, so it's going to come first. And 3 over 2 is the larger, so it's going to come next. Don't forget, this first row is where w lives, where the variable lives. Excellent. I'm going to erase this at this point. Alright, so I'm going to drop my bars here. These are very important points to the product because at any of the two, one of the factors is going to vanish. Well, the first factor, 2w minus 3, vanishes. It vanishes when w is 3 over 2, so it's going to vanish right here, which means before that it's going to preserve its sign, and after that it's going to preserve its sign because it doesn't neutralize again. That's the only time it neutralizes. Let's choose a number before 3 over 2. 0 is a number before 3 over 2. Let's replace omega or w by 0. This becomes 2 times 0, which means 0 minus 3, which means minus 3. So this guy is going to be minus 3 when w is 0. So apparently, right before, before 3 over 2, that entity is going to be all the time negative. So I'm going to denote this by just the sign minus and minus. Now after 3 over 2, this factor 2w minus 3 is going to also preserve its sign. Let's check what the sign is. Let's take a number bigger than 3 over 2. Let's take number 2. 2 times 2 is 4. 4 minus 3 is 1. So that's going to become a positive entity, and which means that sign is going to be a plus. One more time for the second. 2w plus 3 is neutral at this point when w is equal to minus 3 over 2. So it's going to be 0 right there. It's going to preserve one sign before and another sign after. Let's take a number smaller than minus 3 over 2. Let's take the number minus 2. 2 times minus 2 is minus 4. Minus 4 plus 3 is minus 1, so which is negative. And a number and a w bigger than minus 3 over 2, let's say w equals 0, plug it in here. 2 times 0 is going to be 0, plus 3 is going to be 3. So the sign for the entity 2w plus 3 after when w exceeds minus 3 over 2 is going to become a positive entity. So that's going to be denoted by plus and plus here. And what's the interest? The interest is I want to understand when this guy, again, let me call it some number a. I want to know when this guy is going to be 0 or more. So it's going. I want this guy to be at least 0. Well, let's have the last row for this guy, a. A is the product, right? It's the product between the two guys, 2w minus 3 and 2w plus 3. Excellent. Let's see. So a is gonna preserve a sign when w is between minus infinity and minus 3 over 2, and that sign is gonna be dictated by what the factors, by the signs of the factors. Well, the first factor is negative and the second is going to be also negative. As such, the product is going to be positive. When w is at the point minus 3 over 2, one of the factors is 0 and hence the product is 0. When w is between minus 3 over 2 and 3 over 2, this factor 2w minus 3 is negative and the other factor is positive, hence the product is going to be negative because it's minus times plus. When w is 3 halves, one of the factors is 0 and hence the product is going to be 0. And after, when w exceeds 3 halves, each of the factors involved in this game is going to be positive, as such the product is going to be positive. And the question now is, when is a 0 or more? When is a non-negative? Well, look at the row for a. A is 0 or more when w is between those two guys, right? Oh, sorry, 0 or more, so positive or neutral. So a is 0 or more when w is between minus infinity and minus 3 over 2, including minus 3 over 2, because at this point the product is 0 and I'm allowing the product to be 0. Look at this, bigger than or equal to 0. So bigger than or equal to 0 means positive or 0. Well, a is positive between minus infinity and minus 3 over 2, and it's 0 at minus 3 over 2. And it's also 0 at 3 over 2 and positive after 3 over 2. So the solution set is going to be written as follows. The solution set is going to be so the solution set is going to be from minus all numbers, all w's that live between minus infinity and minus 3 over 2, and all numbers that live a mistake, I should include minus 3 over 2, because at this point, one more time, at this point the product is 0 and I am allowing the product to be 0 because I want to the question is I want to solve when the product is 0 or more. So minus 3 over 2 is going to be included, and then any number from 3 over 2 onward is going to also make the product 0 or more. So if a w is given from this set or from this set, the product is going to be a non-negative entity. So both of these sets are good points. To make it one set, which is the solution set, I'm going to take the union between the two. All right, so let's take another problem. Let's consider page 333, number 44. Solve the following inequality. So minus 3w6 plus 8w5 minus 4w to power 4 is less than or equal to 0. Well, I would like to factor this polynomial, the polynomial on the left-hand side. I would like to factor it. And an obvious factorization as a first step is to factor out the greatest common factor, which is w to power 4. So this is the same as saying w to power 4 times minus 3w squared plus 8w minus 4 is non-positive. Next, I want to factor the second degree polynomial. And if you appeal to the quadratic formula, which we talked about in class, or we revisited in class, you can see that this is the same as minus 3 times w minus 2 times w minus 2 over 3. So this inequality that we have. The question is now the same as saying I want to solve w to power 4 times negative 3 times w minus 2 times w minus 2 over 3 less than or equal to 0, which is a product of how many factors this time? 1, 2, 3, 4. So I'm going to have 4 factors, which means I'm going to have 4 rows in my table of variations to start with. All right, let's do it. So table of variations, I'm going to do, again, 4 rows. So this is the first row. This is where w lives. And then I'm going to mention all the factors. One of the factors is w to the power 4. The other factor is minus 3, right? Third factor is w minus 2. And the last factor is w minus 2 over 3. Very good. All right, let's look at the critical points in this context. W4 is 0 when w is 0. So one of the critical points is 0. Minus 3 is never 0, so no critical point. No number making this factor 0. What's the number that makes w minus 2 0? This happens when w is 2. And what's the number that makes w minus 2/3 0? This happens when w is 2 over 3. I'm going to place all these factors on the number line. Remember, this first row is the number line, so this is from minus infinity all the way to plus infinity. I'm going to list all these critical numbers that we found on this number line, obviously while respecting where they are located. So 0 is the smallest among all these, and then the second smallest is 2/3, and then the last one is 2. So one more time. Oops. So one more time. 0 is the smallest, second smallest is 2/3, and then the biggest one is 2. And I'm going to drop my bars here. All right, and let me erase those green ones. Oops, Jesus. Okay, sorry about that. All right, so W4, it neutralizes, as we said, at 0. But W4, all right, so which means before 0 is going to preserve one sign, and after 0 is going to preserve one sign. Well, let's choose a number before 0. For w, take minus 1, let's say. Minus 1 to the power 4 is still 1, so which means it's positive. And now let's choose another number bigger than 0. Let's choose 1. 1 to the power 4 is also positive, so this means this is going to be also positive after 0. And this is not news to us, right? Because look at this entity, w to the power 4. I mean, the least, this is an even power. I'm raising a real number to an even power. I mean, the least it gets is 0. And elsewhere it's going to be, I mean, whenever it's 0, it's going to be, whenever w is 0, the entity is 0. Elsewhere it's going to be positive. So this is not news to us. Minus 3 is an entity that doesn't depend on w, so it's a constant, and that constant is always negative. So negative everywhere. W minus 2 is 0 at 2 when w is 2. Before 2, this entity is going to preserve a sign. Let's choose a number before 2. 0, for instance. 0 minus 2 is minus 2. So before 2, the entity w minus 2 is always negative. And after 2, w minus 2 is going to be positive. Just check, take a number bigger than 2, let's say 3. 3 minus 2 is 1, which is positive. And lastly, for the last row, I guess you understand the game at this point. This neutralizes at 2 over 3. Before that, the sign is one thing, one sign. Choose a number smaller than 2 over 3, let's say 0. Replace w by 0, that's going to be negative. And if you choose a number bigger than 2/3, the entity w minus 2 over 3 is going to be positive. So we're going to have plus and plus here. And then the question is, when is this product, let's call it P, when is this product non-positive? Well, let's create a row for this guy P. And let's see the variations of P. Well, P is made up of all these factors. When w is between minus infinity and 0, this factor is positive, this factor is negative, this factor is negative, and this factor is negative. As such, the product is going to be plus times minus times minus times minus, which is going to be a minus sign. When w is 0, w to power 4 is 0, which is one of the factors in P, and hence the whole product is going to vanish at this point. And we play it again over here. When w is between 0 and 2 over 3, plus one of the factors positive, the other 3 are going to be negative, and hence the product is going to be negative. When w is at 2/3, this factor is 0, and hence the whole thing, the product is 0. Between 2 over 3 and 2, what's between 2 over 3 and 2? W. When w is between 2 over 3 and 2, two factors are positive, two factors are negative, the product is positive. When w is at 2, this factor, w minus 2, is 0, and hence the product is going to be also 0. And once w exceeds 2, 3 factors are positive and 1 factor is negative, hence the product is negative. And now let's go back and see what we really need. We want the product to be 0 or less. So negative or 0. Let's take a look at the variations of P. Negative or 0. This is negative. Sorry about that. This is negative. This is where P is negative. This is where P is negative. And this is where P is negative, when w is from bigger than 2. And now P is 0. P is 0 at this number when w is 0. At this number when w is 2 over 3. And at this number when w is 2. So let's write the solution set then. So the solution set is all these numbers between minus infinity and 2 over 3. I mean, if you want to write minus infinity to 0 union 0 to 2 over 3, this is the same thing as saying minus infinity to 2 over 3, because you're not throwing away anything. So I'm going to have minus infinity to 2 over 3, including 2 over 3, because at 2 over 3, the product is 0. The product is 0, and this is part of the question. I'm allowing the product to be 0. And then I'm going to adjoin all these points to the points that are from 2 onward, because this is where also the product is 0 or more. 0 or less. So 2 plus infinity. Okay, so everything we've done so far stems from the idea, which was about to understand when, to determine the sign of a product. It stems all the way back to this first discussion. To understand when a product, the sign of the product, it suffices to understand the sign of each of the factors. And the same thing we can inherit the same analysis if we want to understand the sign of a quotient. The same thing applies. If you want to understand the sign of the quotient, try to understand the sign of the numerator and the sign of the denominator, and then deduce the sign of the quotient. So let's start applying this line of reasoning to quotients. Let's go to number 68 on page 334. This is the question. Solve this quotient, p squared minus 2p minus 8 divided by p minus 1 greater than or equal to 0. You may think if you multiply both sides by p minus 1, that does the job. So which means you multiply both sides here and here by p minus 1 and get p squared minus 2p minus 8 greater than or equal to 0 as an equivalent statement once you multiply by p minus 1. But this is not correct all the time, because you are multiplying by p minus 1. You don't know what p minus 1 is. If p minus 1 is positive, then yes, this is correct. But if p minus 1 is negative, then the inequality sign has to be reversed, right? Because when you multiply an inequality, if you multiply both sides of an inequality by a negative entity, the inequality sign has to change. So there are really two cases there. It doesn't come on the cheap as you might think. One more time, you cannot multiply p minus 1 both sides and keep the same inequality sign or even change it, except if you consider multiple cases, because p minus 1 has p. This entity is not a constant. It has p in it. It depends on p. What p is, what p is determines what p minus 1 is. So p minus 1 may be negative, may be positive, and if it's negative, the inequality sign has to change. So as such, this is not the approach I'm gonna be doing. What I'm gonna do is I'm gonna just treat it exactly the same way as we dealt with the product. So I'm gonna keep everything as is. I'm gonna try to factor the numerator as a first step, because the numerator, again, you want to understand the sign of the quotient. So let's try to understand the sign of the numerator. Try to study the variations of the numerator, try to study the variations of the denominator, and hence deduce the variations of the quotient. In order to study the variations of the numerator, look at the numerator. It's a polynomial, so I'm gonna apply the same thing as I applied before to study the variation of this guy, which means let's start to factor this entity, p squared minus 2p minus 8. And if you factor it, it's not hard to factor it using either your intuition or quadratic formula. And if you do so, that factors as p plus 2 times p minus 4, and downstairs is p minus 1, and I would like this to be non-negative. Alright, so at this point I'm gonna go to the table of variations and start establishing it. So the first row is where p lives, the variable of the problem. The second row is for p plus 2, one of the factors of the numerator. P minus 4 is the second factor of the numerator. gonna create a new row for the numerator. So based on the information I'm gonna have, based on the variations of p plus 2 and p minus 4, I'm gonna be able to deduce information about the variations of n. And n, again, what's n? It's the numerator. This is what n is. So once you understand the variations of p plus 2, the variations of p minus 4, you can deduce the variations of n. So I'm going to create a row for that information. All right. And then the last thing is p minus 1, which is technically the denominator, right? All right. So what are the critical points here? For p plus 2, the critical point is minus 2, right? At minus 2, p plus 2 is is 0. For p minus 1, it's plus 4. And for p minus 1, it's 1, right? So the critical numbers minus 2, plus 4, and 1, they make each of the factors 0. So minus 2 makes p plus 2 0. Plus 4 makes p minus 4 0, and plus 1 makes p minus 1 0. So I'm gonna put these on the first row, which is the number line. So minus infinity to plus infinity. Minus 2 is the smallest among all three. The second smallest is 1, and then the last one is 4. Then I'm gonna erase them from here. All right, then I'm gonna create my bars. So and let's start understanding. So p plus 2, this factor is 0 right here. Before that, it's going to preserve a sign. That sign again is going to be negative. After that, this is going to become plus. Sorry, I'm doing it quickly because we've done this many times. P minus 4 is 0 at 4 when p is 4. Before that, it's going to be negative. I mean, if you take test points, and after that, it's going to be positive. And let's start and let's deduce now information about the numerator. Well, the numerator is positive when p is between minus infinity and minus 2, because the two factors are negative. So this is going to be plus. When p is negative 2, one of the factors upstairs is 0, and hence the numerator is going to be 0. When p is between minus 2 and 1, I'm going to have negative as a sign, as the sign of the numerator. And likewise here, between 1 and 4, this is also going to be minus. At 4, this guy here, this factor p minus 4 is 0. As such, the numerator is going to turn into a 0 entity. And after 4, the numerator is going to be a product of two positive entities. Moving on to the denominator, which is p minus 1. Well, p minus 1 vanishes at 1. Before that, it's going to be minus, and after that, it's going to be plus. And now let's take a look at the whole thing, the whole quotient. Let me refer to this quotient as q. Let me call this whole thing as q. So what's q? Q is the quotient. Q is the quotient n divided by p minus 1. So I'm going to write here q. This is the information about q, and this is what I want, the information on q. I want q to be 0 or more. Very good. I'm going to focus, just as you may guess, I'm going to just focus on these two things, the information on n, the numerator, and the information on the denominator, which is p minus 1. This is where I'm going to focus, and that's it. Why I'm not going to take into consideration p plus 2, p minus 4? Because the information on these guys are embedded in n, so they are already collected. and then I'm gonna put n as the guy upstairs, information on n, p minus 1 information down, this is the guy making up downstairs, and then the quotient is gonna be dependent on what the sign of n is and what the sign of p minus 1 is. So and what I'm gonna get is when p is between minus infinity and minus 2, upstairs is plus, downstairs is minus, the quotient is minus. At minus 2, upstairs is 0, downstairs not 0, so the quotient is 0 divided by non-zero is 0. Between minus 2 and 1, upstairs is minus, downstairs is minus, quotient is plus, because minus divided by minus is plus. When p is 1, downstairs is 0 and upstairs is not 0. So the quotient q becomes non-zero divided by 0, which is an error. And you can write whatever you want. I'm going to denote this by having this bar here to indicate to myself that this is an error if I get to this number 1. So when p is 1, you can check when p is 1, the denominator is 0, upstairs is not 0, which is the n guy, and non-zero divided by 0 is an error. So this is my notation for error, let's say in this table. Once you are away from 1 to the right, upstairs becomes minus, downstairs becomes plus, quotient becomes minus. When p is at 4, upstairs is 0, downstairs is not 0, so quotient q becomes 0 divided by non-zero, which is 0. And once p goes beyond 4, upstairs is positive, downstairs is positive, quotient is positive. And now the question is, when is q? So now we have all the information on q. This last row is what we need. At this point, we can ignore all the table, and the only thing we need is the last row, which is the information on q. I want to know when q is 0 or more. So when q is 0 or when q is positive. Well, as you see from the table, q is positive here, and q is positive here. And q is 0 when p is negative 2, and q is 0 when p is 4. So all these green points are the points that are good points. So if you want to answer the question before we write it, we finalize it in writing. Q is 0 or more when p is between minus 2 and 1, including minus 2, excluding 1, because remember at 1 q is not determined. Or p should be a number that's 4 or more. How would we write this? So the solution set is given by the following. As we said, minus 2 is a good point, all the way to 1, open, adjoining these guys to all numbers that are from 4 onward.